Hi all, this is Shweta Reddy, working as Assistant Professor in the Department of Electronics and Communication Engineering from R.M.K College of Engineering and Technology. So today in this video of transmission lines and waveguides, we are going to see a topic on applications of Maxwell's equation to the rectangular waveguides. So let's move into the topic. So coming to rectangular waveguides, we'll see what are waveguides first. So waveguides are nothing but a hollow conducting metallic tube of uniform cross section which is used for propagating electromagnetic waves. Waves that are guided, waves that are guided along the surface of the tube is called, is generally nothing but a waveguide. And let us move into the first topic, that is applications of Maxwell's equation to the rectangular waveguides, or the other heading is general wave behavior in a rectangular waveguide. So as we saw earlier in applications of restrictions to Maxwell's equation, which is in the fourth unit, the same process we are going to proceed here, but there are some different steps which we are going to use. So we will see that generally, there also we have started with the general equations for field components. Here also we are starting with the general equations for field components from Maxwell's equation. That is nothing but these two equations. Del cross H is equal to j omega epsilon E and del cross E is equal to minus j omega mu H. So as I mentioned earlier, what and all we have seen in the applications of restrictions to Maxwell's equation in fourth unit, the same process we are going to repeat here. Then the next step we have seen there is the electric and magnetic field equations. These are the electric and magnetic field equations, that is for E, Ax vector Ex of x comma y plus Ay vector Ey of x comma y plus Az vector Ez of x comma y e power minus gamma z. And for H, that is magnetic field equation. H is nothing but Ax vector Hx of x comma y, Ay vector Hy of x comma y, and Az vector Hz of x comma y e power minus gamma z. So we are assuming that the direction z is equal to 0. So e power minus gamma z will be becoming 1 in both the equations. This is what the this will be neglected as 1, and we will be having this equation alone. So the same process, that is for rectangular coordinates, we have to find in determinant form, that is del cross H is equal to, we are going to have Ax, Ay, Az vectors and dou by dou x, dou by dou y, dou by dou z, and since it is H, we are having three directions Hx, Hy and Hz, which is nothing but j omega epsilon E. Now instead of E, I can substitute this equation. So instead of E, if I substitute this equation, I'll be getting this. So after that, I'm going to take determinant, that is Ax determinant. If I take determinant for the above equation, Ax vector dou Hz by dou y minus dou Hy by dou z minus Ay vector dou Hz by dou x minus dou Hx by dou z plus Az vector dou Hy by dou x minus dou Hx by dou y. And this j omega epsilon E, I am going to take it into inside the bracket. For all three terms, if I take inside the bracket, I'll be getting j omega epsilon E Ex Ax vector plus j omega epsilon Ey Ay vector plus j omega epsilon Ez Az vector. Now in the left hand side also I have Ax, in the right hand side also I have Ax. So I'm going to equate the Ax terms alone. Similarly, in the left hand side I have Ay, and I'm having the right hand side also I have Ay vector. So I'm going to equate Ay terms, Ay vector terms. And similarly, I have Az vector in the left hand side and Az vector in the right hand side. So I'm going to equate Az terms also. I'm going to take all these three equations as fifth equations. So I have completed the equation for del cross H. Now the same process we are going to repeat for del cross E. So if I repeat the process, del cross E is nothing but same process, that is Ax vector, Ay vector, Az vector, dou by dou x, dou by dou y, dou by dou z, and the three directions of Ex, Ey and Ez, which is nothing but minus j omega mu H. So instead of H, if I substitute instead of H in the previous equation, we got like this, that is Hx Ax vector plus Hy Ay vector plus Hz Az vector. So instead of H, I'm going to substitute this, and I'm going to take determinant for the above equation. If I take determinant for the above equation, I'll be getting Ax vector dou Ez by dou y minus dou Ey by dou z, and Ay vector dou Ez by dou x minus dou Ex by dou z, plus az vector dou ey by dou x minus dou ex by dou y, which is equal to, I'm going to take this j omega epsilon, j omega mu inside the brackets for all three terms. So if I take inside the bracket, I'll be obtaining as j omega mu hx ax vector minus j omega mu hy ay vector minus j omega mu hz az vector. Now similarly, I'm going to equate the terms of ax vector, ay vector and az vector. So I have ax vector in the left hand side as well as right hand side. So I'm going to equate the ax vector terms, and I also have ay vector in the left hand side and ay vector in the right hand side. So I'm going to equate the ay vector terms, and similarly I have az vector in the left hand side and az vector in the right hand side. So I have obtained these three equations, and these three equations are marked as equation number 6. So now, what we did there in the applications of restrictions to Maxwell's equation is, next we have found that the wave equations. As we seen earlier, the wave equations are del square E is equal to gamma square E and del square H is equal to gamma square H. We also know that gamma square value is sigma plus j omega epsilon j omega mu. For non-conducting medium, the value of sigma will be equal to 0. So after substituting the value of sigma equal to 0 in gamma square, and finally substituting the value of gamma square in dou square E and dou H square, I'll be obtaining the results as del square E is equal to minus omega square mu epsilon E and del square H is equal to minus omega square mu epsilon H. Now expanding the above equations, that is, I'm going to expand this del square E in all three direction x, y and z. So I'll be getting dou square E by dou x square plus dou square E by dou y square plus dou square E by dou z square is nothing but, I'm going to write this RHS as it is, that is minus omega square mu epsilon E. Now I'm going to expand this del square H in all three directions. So I'll be getting dou square H by dou x square plus dou square y by dou y square plus dou square H by dou z square is equal to, and similarly the RHS will be same, that is minus omega square mu epsilon H. So this is what we have seen in this video. We will be continuing, that is assuming this hy is equal to hy naught minus gamma e power minus gamma z in the next coming video. Thank you all. We will be seeing the continuation of this applications of Maxwell's equation to the rectangular waveguides in the next coming video.